All right, I am not seeing the attendee list move a ton. So if more people join us, that is fantastic. But if not, we're going to get going. All right, so I'm going to take you through, if you've never joined me before, I'll introduce you myself and then take you through a couple quick PowerPoint slides just to talk about why we're here. And then I'm going to take you right into the software and we're going to spend the rest of the time in AutoCAD Electrical. Apologies if you're looking at my video. I have not bought blinds for my house and I'm being blinded by the now with the time change where the sun is during this particular webinar. So I may be leaning a bit. Um, so I am Tiffany Bachmeyer. I lead the manufacturing consulting team here at Autodesk, and I also am a resident AutoCAD electrical expert. So that is the hat that I'm wearing today while I join you. Happy to and excited to take you through this. We do this every month on the first Thursday of every single month. So really excited to share this with you. Thank you for joining. Hopefully you find this beneficial. And then at the end of the PowerPoints, I'm actually going to talk a little bit about what's coming this month. So let's dive right in. So boosting our productivity, first of all, if you are currently using AutoCAD, perhaps you're doing it just to do controls drawings, maybe you're using electrical, but you're still using it as AutoCAD. Perhaps you press a button here or there because you think, oh, this could be really handy, but you haven't fully embraced everything electrical can give you, then this is absolutely the webinar for you. We will be discussing all of the amazing automation that AutoCAD Electrical can bring you, as well as what that error reduction or what error reductions happen due to that automation and all of the other capabilities that we have within it, including error reporting tools and things like that. So really, really fantastic tools and really excited to bring this to you today. Now, some of the things that we talk about on why, and trust me, I love vanilla AutoCAD. I started on R10 many, many, many years ago. It is a fantastic package, but when you're doing specifically controls design, there are a lot of things that become quite manual when you're doing that in vanilla AutoCAD. So the beauty of this, of what AutoCAD Electrical brings us, is the benefits and all of the love and the comfort of our space within AutoCAD, but giving us all of these other great extras, these automation tools, these extra, think about them like macros, combined commands that you would have to do very manually in AutoCAD that are all brought together inside of AutoCAD Electrical. So manual creation of symbols, manual tagging, manual cross-referencing, manual reports, manual editing. These are all the things we have to do when we're just in vanilla AutoCAD. It's painful. Now, in AutoCAD Electrical, we get over 2,000 symbols already built standard. So they're based off of the actual government standards for IEC and IEEE and the NFPA, which is part of the IEEE standard, and all of the other tools that we have between, and I'll show you all of these, but we have the Australian, Japanese, and Chinese standards as well. So many different symbol libraries in there. Automatic tagging, real-time cross-referencing, so it doesn't even ask you, it just automatically is cross-referencing back and forth across pages. Beautiful thing. Automatic reports, and I have this in bold, it's such a simple tool, but it's such a manual process if you have to do it yourself, is the title block update utility. If you've ever heard any of my webinars before, I use this anecdote often, but it is true, and it's how I got into AutoCAD Electrical. I started with the title block update utility. I had to update over 500 drawings with just the title blocks back when I was in the industry working at a conveyor OEM, and I was tasked with doing that, and I thought, this is crazy. I am not manually editing all of these title blocks. There's got to be a better way. And I downloaded a trial of AutoCAD Electrical. It was right when we had first acquired it and then moved it into AutoCAD in 2004. And I put that in, was able to bring all my drawings into the project manager without even having to turn them into electrically intelligent drawings, but I was able to run the full title block update utility, and I had all of my drawings done within an hour and handed them back to my boss, and he was shocked at how I could get all of that done so quickly and said, how did you do this? And I said, AutoCAD Electrical, and we're getting it. And he agreed. So that's where it started for me. So really, really amazing utility. And I think you guys will all find benefit in it. Now, this productivity study was from a couple years back, but I still find it to be very, very interesting. So just think there's probably even stronger productivity abilities now. But the creation of new designs was 84% faster within AutoCAD Electrical versus vanilla AutoCAD. Editing of existing designs, 77% faster. And error reduction was massively reduced because of the 67% reduction in the number of commands used. That's a lot. If you think about how many commands that removes from what you have to do manually in AutoCAD, that's a big number. So really like the study and just like to share it with you guys. So all right, last thing, and this is what I was mentioning earlier that I said I was going to pause quickly to talk about. So in 2 weeks, slightly less than 2 weeks, actually, we're only about a week and a couple days away from the kickoff of it, but exactly 2 weeks from today is when I will be actually hosting the AutoCAD Electrical Meetup at Autodesk University. So it is our the third Thursday of every month version of this, the one where I typically have office hours, open office hours, or what we call the AutoCAD Electrical Meetup, where you can bring any questions anytime, beginner, intermediate, advanced, and we go through them live during that hour. So it's just an open forum to meet with anybody else that that has questions from across the globe that just wants help with AutoCAD Electrical, and you can ask the experts. I'm joined typically by a vault expert on my team, Matt Durst. He's amazing, and so he helps answer those questions as well. Tom Fitzgerald, also on my team, inventor expert, absolutely phenomenal. They actually did the EMX version of this for us in the last demo last month, if you guys joined that. So they did an open office hours with a little special presentation on the EMX workflow, and that's the workflow between electrical and inventor. So I will be there live. If you will be at AU, I really hope you sign up for this meetup. There are only a select number of spots, and I believe I'm almost full. So go grab those for those couple open spots that are left. If you are available, I will be thrilled to meet you in person. And then any of you guys that aren't attending AU but want to still join this, we're going to stream live from AU. So we will still have our standard office hours that we have, but we'll be live from AU and you'll be able to join us from there. So really excited about that. And excited about AU in general. It's going to be a great year. Lots of amazing things happening. I have my entire team there. The growth in manufacturing, both in the design and make space, is just huge. Really exciting things that we're going to be doing and getting involved with. So if you're at AU, I really hope to sync up with you. Really would love to meet you in person, whether it's at this meetup or just in and around AU and all of the fun festivities and activities. So please feel free to reach out to me via the AU app. I'll be in there. You'll be able to reach out and you can chat with people via that. So you can find me and I'd be thrilled to meet up. So just wanted to talk about that quickly. And then we're going to dive right in now to AutoCAD Electrical. All right. So jumping in here, and I got your note, Mark. Thank you. So excited to see you at AU. Always good to see you every year there. It's a good time. Hopefully there will be more of you too that'll be there. All right. So let's talk a bit about in general, what makes AutoCAD Electrical so different than vanilla AutoCAD. We're going to go through a series of different things, but we have to start with the foundation, and the foundation is the project file. So as you can see on my screen here, I have at the top level of my project manager here, I have, and that's what this is. So this is the first big difference between AutoCAD Electrical and AutoCAD is we actually work with our drawings via the project manager and not going up to something like file, new, or open, because you don't want these files to all just be independent of one another. They are their own DWGs, so they can be opened by somebody who just has vanilla AutoCAD. But the beauty of this is when we consume them by a project file, like you're seeing here, they are now connected to one another. So they can be cross-referenced across drawings. They can be, reports can be run on all of them. So this is the beauty and the key to the functionality of all of the connection that we have between all of our drawings. And this could be 2 drawings in it, or it could be 100. So you can have, and it could be more than that. I hope you don't have project files that are significantly more than 100, because those are some big project files, but you can have them if you need them. I would love to see those though, because that's some serious projects that you've got going on. What mine looks like here, it started with 10. There's been a few additional, so we're at about 16 drawings within this particular project right now. So healthy project, but not anything crazy. So when you look at this, and you can separate, you don't have to have folders. These folders are not Windows folders. They're not meant to be locations of where they are saved. The drawings are saved actually with the project file. This is to help you organize. So you can organize your drawings by schematics, by panels. You can see the rest of these are floating. They're not actually consumed by a folder right now, but I could create a new folder to put those in. These are PLC drawings, so I could create a folder called PLCs. So they're just a way for you to be able to organize and quickly find your drawings, especially if you have those larger projects like the 100+ ones that we were just talking about, just much easier to navigate. It also allows you to run project-wide commands on a specific group of drawings. Now you could manually pick them every time, but the beauty of the folders is you could say, I want to run a project-wide update on just everything within that schematic folder. So you can do things like that. So they're kind of like mini projects within the grander project. So lots of different ways to use those folders, but really good tips and tricks there. Oh, by the way, I should talk about that too. One of my AU classes is actually a hands-on lab this year. So I often teach a beginners, what I call it, feeling the spark for AutoCAD Electrical. At AU, I've done it in a couple different forms in the past, but never actually as a hands-on lab. So that's what we're doing this year. So you can actually get your feet wet a little bit, get in there and try it out. So a lot of the things that I'm going to do in my demo today, you'll actually be able to do in that class. So if you're coming to AU and you're looking to get more experience with AutoCAD Electrical, please join us for that hands-on lab. Feel free to sign up for it, and it'll give you even more experience in getting to walk through some of these key skills that you can get with AutoCAD Electrical. All right, so back to the project manager. So what the project manager also allows for us is the ability to set standards that we want across all of the drawings. So we have things called project properties. And I was a little worried. There we go. My computer seems to be a little bit cantankerous this morning. I actually rebooted right before I started this webinar because I wasn't even getting Outlook to function properly when I was trying to join meetings. So hopefully we are good to go, but I still feel like I'm seeing the slowness even after the reboot. So apologies in advance if things are a little bit wonky today. It is what it is with live demos. But in here, in the project properties, we can define all sorts of things. Now, first of all, we can define what our libraries are that we're going to be using. So I already mentioned that we have standard libraries. So I'm using the NFPA library based off of the NFPA 79 standards and the IEEE 315, 315A standards. NFPA is imperial form. If we browse and we take a look at the other libraries that come with the software, you will see that there is also the legacy JIC. That's really just for people who used AutoCAD Electrical in the past and still have projects on that. You don't need that. The updated versions are NFPA and IEEE. IEEE is the US standard in metric form. We also have, like I mentioned before, IEC for the international standards. This is the newest one. The 2 and the 4 are the legacy ones, as well as the Japanese, Chinese, and Australian standards. And then what we have are what we call our peer devices or our peer libraries, and we have hydraulic, pneumatic, and P&ID symbols. So you can combine all of those to all be managed by the same electrical project, and you can do connections between those peer devices. So, and then obviously we have a panel library as well that gives us all of our panel footprints. So if you choose to do your panel footprints here in electrical, you can absolutely do that. When we say panel footprints, it's not just a panel. It doesn't have to be a true enclosure. It could be, I told you I was in conveyor design. It could be the full mechanical conveyor and you're showing where you're placing devices on it. It just means it's the physical representation of the schematics that you're designing. Now we can also do that in Inventor. I already talked about the electromechanical workflow, another class I'm actually teaching at AU again this year. A slightly different flavor from the times I've done it in the past, but I often get an EMX class in there because there is so much connection now between electrical and Inventor. I will be joined by my esteemed colleague, Tom Fitzgerald, who will be doing the Inventor portion of it. He is an absolute rock star to Inventor. He is teaching some of his own classes on Inventor automation and some really amazing things at AU. So he will be joining me for that class. We'll be teaming up once again to do that. So hopefully you guys can join that as well if you're there. So again, panels can be done in 2 different ways. We'll talk about that when we get to panels, but jumping back in here. So obviously I'm on the NFPA. I just want to show you all the different libraries that you can assign per project. So you can set a standard library that you use most often. So that's what will come in by default, but you can use any of the libraries anytime. You install them with the install of the software. So you choose what libraries you want. They're all free. They all come with it. It's just you choose what you need so that you don't install more than what's needed for you. So you choose that as well as choosing what manufacturers you want included in things like your catalog database and in the panel libraries with what manufacturers come in with those. All right. Now, we also have things in here like the standard component tagging references and wire number tags and how they look and how cross references are handled and how arrows and PLCs and how wires cross and tee off of each other. And then even what your standards say ladder widths and sizing are, spacing, all of that. So these are all standards you can set with electrical to make sure that everybody, when they're working in the project, are using the same standards, the same spacing, the same formatting, all of that good stuff. Now, the other really cool thing about the project file is what I mentioned where it's connected across multiple drawings. So I want to give you an example of that by utilizing a tool that we have called the Surfer tool. If I right click on this component and I go to Surfer, what it's going to do is it's going to scan my project for all things related to that particular device. So I now see that I have the parent device, which is what I already selected on. That's the P. And if I were to double click on each one of these next ones, it's going to zoom me right up on it. It's going to show me the related devices. So this is a child contact to that parent device. This is on another page. You'll see in my project manager, it's jumping to page 6. I am now on another child device here. And then this pound symbol is the footprint symbol. So that physical representation that we talked about, this does happen to be in a panel. But again, it could be just the physical representation out on whatever device, but you can see here that it zoomed me right up on it, and I'm now seeing the physical representation of that particular relay. And then I can go back to the beginning. So that is the Surfer utility. And this can be used for all sorts of things, but I always show it here just so you can see the power of what that project file does for us. It allows us to move through, we hit 3 different drawings there, looking at all of the related devices to this particular device that I just chose. There are other capabilities of the Surfer. We won't dive into all of that right now, but I just wanted you to see that connection between all of those drawings. All right. And Todd, I noticed that you had a question. Do peer libraries get installed automatically or is it some type of import? Nope, they install automatically. In fact, you don't even have to choose those. Those just install by default. You choose whether or not you want NFPA, IEEE, IEC, all of those other ones, but the peer ones always come when you install no matter what. And they're actually located, if you were to go to place them into a drawing, they're located underneath the insert component section. They're located here. So the 3 icon menus that have all of those devices are right here underneath. Great question. Okay, so we've talked about the libraries, we've talked about the projects. Let's actually start adding some components in here. So first thing, I'm going to add a new rung here. Now I can go up to the add wire command, but that means I have to click from point to point to do that. Where we have extra commands that have things like add rung when you already have a ladder in. So if I do that and then you choose your wire types, so this is something you build into your template file. So you use a standard AutoCAD template, just like you would in any other vanilla AutoCAD situation. It's a DWT file. And I recommend you save your title block, all of your information. Again, that should all be in paper space for when you want to plot. But other things that you would put in there would be all of the layers that you want, because wires are layers. These are the only layers we really talk about in AutoCAD Electrical, because the rest of them are already done automatically, but depending on what you place into your drawing, it moves them to the associated layers. AutoCAD Mechanical does this as well. So yet again, something you don't have to think about. You don't have to do that like we do in vanilla AutoCAD, where you're moving objects from layer to layer, changing the current layer, all of that. You don't have to do that. But we do add our layer names into this to define all of our wire types. So when I've helped customers implement electrical, I often do this where I get this into their template. And they might have upwards of 20 to 40 wires, but you just build it into that template file and then they're there for you every time. I only have 3 here, but I'm just going to grab one of them. And I'm going to drop this in between both rungs. Notice I was not exact about how I did it. I just clicked really quickly and it automatically snaps. That's because it knows intelligently what that snap setting is for all of your ladder. It knows the ladder spacing. It knows the next rung that's available. It knows where to drop a wire in. So that is adding a rung. And then I am going to come up to my icon menu. And you can see the icon menu here. You can create your own custom symbols. Obviously, we come with many, but you always want to create your own. Everybody does. You can see it's kind of a little bit of a joke that I put my face on here, but it just shows that you can put any PNG images in, as well as being able to set up your own custom libraries and things like that in here. But I'm going to come up to relays and contacts, and I am going to grab a relay coil, and I'm going to drop that in right here. Now, this dialog box, you can give it as much or as little information as you want. You can see the tagging has automatically come in. That is the benefit, again, of those project properties that we talked about. So it's coming in by a standard reference setup as, and we call these replaceable parameters, as a, well, this is the %F part of it. That's the family code of the device. And then the %N is the line number. So I'm on rung 417. So that's why it's putting a CR 417 on there. Does that automatically. Now, we can add description information. You can manually type it. You can also look at what other descriptions have been done in this drawing. So maybe I know this is my next safety relay. So just to make sure that everything's typed the same way, I can just grab that from the list. You can also go to this file that's the defaults section. And what this default description file does is it actually allows us to define, as our own individual companies, all of our standard descriptions that we would want, so that, again, everybody is following standards. So I don't have somebody shorthanding something where somebody else isn't, or somebody else just types randomly whatever they want as the description, as opposed to keeping the standards that we're trying to use as a company overall. So this one is just the generic file. It comes with some basics, but you can edit it to be whatever you need it to be for your company. Now, one of the beautiful things in here as well is a language converter. So you can see that there's actually just French examples and just German examples, or there's dual. So you can have from line 1 to line 2 multiple languages. And we can do that language edit all in here. So you can actually say, I want to take this English phrase and move it to Japanese, or to German, or to whatever it may be. So we can do that as well in that default file. Now, probably the most important section here is the catalog data, because that's obviously going to allow us to get our bill of material information that we need. So we would come in, and again, you could do the same thing. You could look at what's in the drawing already, make sure that you're using the same part number. That makes it very fast, but I want to show you a lookup on the entire catalog. We have over 1 million part numbers that ship with the software. You can see that there are some pre-baked filters in here on this. It automatically goes to whatever category the device that I inserted is defined at. You can switch the categories though, but I'm on the control relay table. This is a Microsoft Access database file. You can also set this up to be a SQL database. So you can actually flip the Microsoft Access database to being managed by SQL, and you can set things up that way as well. That came to us in 2017. Now, from here, I am going to choose, let's just choose one with only 2 contacts on it. So that's going to bring that device in, gave it an item number because it's already seeing that part number in my drawing set, so it found the item number for it. And it automatically assigned pins, and that's because the pin list information is tied to the part number. So as soon as I assign that part number, it knows the parent pins as well as knowing the children. So when I go into the normally open, normally closed setup, it knows there's only supposed to be 2 contacts to this, and it knows the pins for those. If I try to exceed 2, if I try to add a 3rd one to this device as the parent, it's going to tell me that I'm exceeding the limit of that part number. Now, this also means that real-time cross-referencing happens. So as soon as I put the first child component in, it's going to automatically know to give it those pins and then assign it this cross-referencing information. So I don't have to do anything to this section of the dialog box. That happens automatically. All right, now installation and location codes are the last part. So I'm going to talk to you about what they're intended for, and then I want you to understand that they're tools that you can have, they're fields that you can filter by and use for anything that you want. So technically, installation and location codes are very similar to one another. Your location code could be very generally what you where you know you're going to have this located. So I might say that this is on operator station 3. And then I might want to be more specific in my installation code on the very specific location within operator station 3 that it is. People use this for a lot of other things though. Most of the time people don't use it to that granularity. So a lot of times people will use this extra field for something else that they want to include in that particular device, just to be able to filter and run reports by it, because you can run reports on specific installation or location codes. So you can use that to do additional filtering. And I'm sorry, you guys, I am consciously aware that I'm very stuffed up and I probably sound very nasally right now. I'm fighting a cold that I hope is gone by AU. But apologies for that as I'm speaking through that. I might be doing a lot of sipping of water as we go. So I'm going to click OK on this. We're going to see it insert. It's going to ask me about mapping this to the catalog. This is a really neat thing where you can actually have your schematic symbols mapped to catalog numbers. So we already do that in the panel. The panel footprints are tied to part numbers very specifically. As you can imagine, a footprint is very specific to that particular part number because of the shape and the size that it takes up. schematics are much more generic, so they can be used for many different part numbers. But if we want to map them to a certain part number, knowing I will use this particular schematic every time I use this part number, then that builds up the catalog itself, and you can insert direct from the catalog. So you could just go find your part number and then have that insert automatically, as opposed to going to the icon menu and then adding the part number. So just an extra piece of functionality there where you can save an extra step. I am not going to map it. I keep my database pretty clean just because of the nature of how I do the work that I do, but you guys, I would highly recommend that you say yes to those things. Now, in here, you can see it automatically trimmed the wire, placed the component, moved all of the information that we had in that dialog box to the appropriate places, and you can see it's all on different layers. So even though it's one in the same of just one block, all of these different pieces of the block, the different attributes and the block itself, are all actually being moved to the appropriate layer. So you can control the location code on its own layer, the tag name on its own layer, the pins on their own layer, the description, and so on. So it's now ready to accept the cross-referencing information that I have here. So I'm going to add a child component just so we can see what that looks like. So I'm going to go to the icon menu. I am going to go into contacts. I'm going to drop this in. And now notice the dialog box, very, very different, because now all it needs to know is who the parent is, and the parent's information fuels everything else within this dialog box. So child dialog box is very different than the parent one. Now we can look at a list from the drawing, a list of over the whole project, or if the parent or another sibling that it's related to or is on the same page it's on, we get to do just a grab. So that's what I'm going to do here. Click on that, and all of that information comes in. You can see that first list of pins coming in. It obviously knows the cross-referencing information. We drop it in. Again, it fills out. All of that information comes in here, and ta-da, it automatically real-time updated the parent with that child device information. So all of that happens. That's the real-time cross-referencing, all those great updates. So that's parent-child relationships and just inserting schematic symbols. All right, so let's talk a little bit more about wiring. This is obviously a standard ladder drawing. I want to show you that we also support, obviously, schematic wiring for point-to-point wiring. So I'm actually going to jump projects, because I jump around projects a lot based off of the different things that are turned on and off in my projects. Yep, things are still moving pretty slow on this computer today. So I just want to show you the real-time collision avoidance and all of that we have. So I'm going to go to my wire command. I am going to change my wire type to white so that it's a little bit easier for you guys to see. And I'm going to go from point to point. So I'm just going to click from point to point. So connector to connector, or terminal to connector, I should say. But notice what just happened. So I went point to point, it realized it needed to snap up, and it automatically did that. You can see the looping that's happening, and that's just because of my settings. You can have that be different. And notice it avoided collisions. It wasn't going to run into this one, take the same path. It jumped over it, and it moved it. Now, we do have commands like the scoot command, where we can execute that to have it move. You can move it completely outside. You could just shift it over a little bit, but that's only if you want to, you know, work on where those settings are on that, but it will always do all of that avoidance for you, and you don't have to remove things and adjust them. So that's the beauty of the collision avoidance and point to point. The other cool things that we have something called a multi-bus tool, where we can connect to multiple components or multiple buses. And I think I'm gonna have to turn off my snap here. And there we go. Okay, oh, just missed it. There we go. All right, so I can make multiple connections at one time, and then I can even start to turn to get all of my wires to go in the directions that I want them to go. So this is just a neat way to grab multiple wires at one time and not have to manually do each one, and then they have a much more uniform look within your project. So just kind of a cool, quick thing, but I just wanted you guys to see that. So point to point, very easy. Obviously, this is a bit of a composite drawing. It has ladders in here, but we're also going point to point between connectors and terminals. But you can also do just very natively point to point drawings if you want to do that as well. Okay, so that's some more wiring info. Let's take a look at some of the editing commands that we have. I'm just going to jump drawings in this project over here. So if we were to take a look at, if I were to just kind of, let's say, goof this drawing up just a little bit. So let's say I were to use that same scoot command, and you can, scoot is amazing in itself. If you think about what you're doing here from a vanilla AutoCAD standpoint, you're moving you are extending, trimming, adjusting, recentering the wire number, so it's keeping all of the standards and the things that I've set in place together. But I just wanted to give this a little bit of a jumbled look, because what I'm going to use is now the align command to bring all of these back together. And you could window around this or single select them, it's up to you. But you choose one as your master, and then everything can come in align. So if you weren't using snap spacing and you wanted to clean up your drawings a little bit, we have a lot of really great, what I would call smaller editing tools that allow you to get a much cleaner drawing set, like the align tool, like the scoot tool, things like that. All right, now let's talk about, we've done a lot with the schematics. Let's talk about what a panel connection would look like. So I am going to activate a different project. All right. So this is operator station 3. Let's say I want to add a few more buttons to it, because I know I've added them in the schematics and I want to show them now in my panel. Obviously, this is if you're doing it in AutoCAD Electrical. If you choose to do your panels in Inventor, that is a different workflow, but also connected to your project set. Electrical and Inventor talk to one another and share all that information. But I'm going to come up to my panel tab of the ribbon. So you can tell our ribbons are very task-based for what we're doing within Electrical. So I'm going to come underneath my icon menu this time, and I'm actually going to pull a schematic list from what I've already done in this project, because there's no point in recreating everything that I already did. Let's leverage it to make it easier and faster. So I'm going to pull a list of all the schematic components that I already have in the project. And then what I'm going to do is you can either mark them as existing or you can hide existing. That's what I like to do, because then I know exactly what I still need to add when it comes to the panel. And then you can also sort these lists. This is saved actually across all of your sessions. So my same favorite sort is already saved in here, but you can choose to sort however you want. I'm sorting by tag name because that gives me the device types as well. And so what I'm going to do is come down and find the push buttons that I want, and I'm going to grab both of these. So I'm going to shift select them. And then notice that they have catalog information. If they didn't, when I click down here, I don't get the insert button, because the panel footprints are driven off of the part number you've put on them, because as we talked about, they're obviously very specific size and shape based off of that part number. So I'm going to insert them here. And I know this drawing pretty well, so I'm going to use uniform spacing. So you can easily grab a bunch at one time and put your own spacing in. And I don't need to see the dialog boxes for them, because I already filled them out in the schematic, so I don't need to relook at them. If you were doing a big group of them, you can move them up, move them down, reorder them to get them in. Like I could do an entire row of these at one time if I wanted to, knowing the spacing, and just plop them all in at once. Makes it really easy to hammer out your panel drawings. So I'm going to click OK on this. And then I'm going to go back to some vanilla AutoCAD skills here, right? So I'm going to go back and I'm going to use object snaps and object snap tracking to line up my first one, because I want it centered on both of these. And then it's going to plop itself in, and then it's going to automatically add the other one, because I knew that it needed to be at 2.5 inches below the other one. So that's the beauty of being able to use that uniform spacing. And then it pops me right back in here, and I can go on adding more components as I need to from my schematics into my panel. Now you can also add things like the nameplates that you see here. So that would be going back to our icon menu, and I can pop in a nameplate. Now we have generic nameplates as well as catalog lookup versions. So what I'm going to do is I'm going to go to an 800T half round, and I'm going to grab that one. And then I'm going to apply it to both of these. And when you do that, your nameplate then becomes a child component of your footprint. So you've already seen in the schematics when a panel, when a parent and a child are connected to one another, they automatically update, real-time cross-referencing, all of that. By now connecting these panel footprints to those schematics as well, now all three will update together as needed. And now when you add the nameplate to that, the nameplate is basically a child of that panel layout. So, or of that panel footprint, I should say. So if I were to add the description and change it or modify it, it would automatically update on the nameplate as well. And then we can run nameplate reports that will draw that out so that if we're stamping our own nameplates or if they're stickers and we're doing that in label makers, things like that, you can do all of that and you can pull that information automatically as opposed to manually have to put that data in to get those created. So that is the benefit of all these things being connected. You only have to modify in one place, everything updates, and we click OK on that and we have them there. And we can even do really easy editing of attributes, things like that. I can move with the grips, or I can use the attribute tools to actually move these attributes in these blocks to get them to fit, things like that. You can make small adjustments. The key to AutoCAD Electrical, though, is there really should not be manual effort. So it should be one-off times where you have to do that. If you're doing it every time you insert something, something's probably up with the block. You need to edit the block to make it what you need it to be so that every time it inserts, it goes to the location that you want it to. You shouldn't have to manually hide attributes or move attributes or things like that. They should already natively come in the way that you need them, and it should only be for those one-off situations. And that's the beauty of electrical. Really nothing is manual. It's all very quick and easy. And again, I say if you're finding yourself doing a lot of manual tasks, something's probably not set up right. We need to update it from the core functionality of it as opposed to doing it every time you place something inside of a drawing. So, okay, so let's look at now some of the reporting tools that we have within the software. So I'm going to actually jump back to the very first drawing that I had open, and we'll go back and activate that guy. So you always want to work in your active project. You can have as many projects as you want open inside your project manager, but we're always the one that we're working on, we're going to do project-wide commands, things like that to it. That's always the active project. So you have one active project at a time. All right, so I am going to run a few audits and then a few reports. So if I go to the reporting tab here, I can see that I have two different auditing tools. I have a DWG audit and I have an electrical audit. The DWG audit is a very quick audit to basically look for what I would consider bad drafting skills. So kind of sloppy things that happen. Maybe you did some manual deleting of things. You didn't use the tools to delete and clear things out. So it maybe deleted a wire but didn't delete the wire number because you were using just the delete key on your keyboard as opposed to activating the tools that we have within electrical. And what this does is then cleans up all of that. So you don't have floaters of wire numbers that aren't associated to any wire anymore, things like that. So this is a quick cleanup of that. The one other cool thing that it does though, is it gives you, if you do it just on the active drawing, it will give you a quick display of all of your wire networks. So it'll show you by pointing from the wire number to all the wire networks where all of your wire networks are in your drawing. As soon as you zoom, it's gone. It's just a quick visual to make sure that you're seeing everything the way you intended it to with those wire networks. So that's kind of a cool thing about that audit. The much bigger, more powerful audit is what we call the electrical audit. There are 10 different categories of things within this audit that it looks at. Now, don't get caught up on the fact that you're seeing this say that there are 649 issues found. They are more than likely not necessarily issues, although that's a high number. So I want to kind of look at this project. I'm wondering if I've perhaps deleted some pages that should have been in there when I was working on different training aspects of this that might need to be cleaned up just a bit. But if you look, wherever the column is that it has a red dot with the white X through it, that means it has found what it considers to be potential issues on those particular searches. So I tell everybody, if you were to take a class with me ever, I would tell you that I have a top 3 on here. I'm not saying that all 10 of these aren't important. They are, especially if you're seeing some issues within your drawing set. But as a general basis, every single time I finish a project, I check these 3 particular columns every single time, and I'll tell you why. The first one is the wire no connection. What this one tells me is if I am missing source and destination arrows. So I'm going to tell you right out of the gate, the 3 that are on here are not actually errors, but I'm going to show you why. So you can zoom right to these things. So this is a really great way. You can keep this up on one screen and just cruise through your electrical audit on the other screen because you can make your edits on the fly. So if I were to move it over here, I could do that. I'm going to keep it obviously on the same screen though so you guys can see it. So what this is, the 3 that it's showing are the start of the entire project. This is the main breaker. This is the beginning of the entire flow of all of the project when it comes to wiring. So it's really not an error. I could put a dummy terminal at the end of it just so that it does truncate at something, but that's really, it's not necessarily needed. But that's why I know. Now, if anything else was on this list, though, I'd be very concerned that I was missing a connection, because you can see what's happening. This just means it's a dangling wire here. So for instance, if it was showing up that it was down here on this end, I would know I forgot to put a source or a destination arrow on there to send that wire out to somewhere or to be received by somewhere. So we do obviously have source and destination arrows. That's how the wires travel across every drawing in the project. And this particular check tells me whether or not I'm missing things like that. My other big one, I'm sure you can imagine why, is the component no catalog number. If I have components in here that have no catalog numbers, and I have a feeling that's why this has grown so big, because I added a bunch of drawings in here from the PLCs that didn't actually have catalog numbers on them. So I'm assuming that's why. But what this means is these aren't going to get ordered. If I'm putting these devices into my project, but I never put a catalog number on them, now they're not going to go out into my BOM, so they're not going to get ordered. So I would always just crank through these. In fact, I could double click right on it. You can see where it'll take me, zoom me right up on this light. I could go in, edit component, and add a part number right to it. So you can crank through those, add your part numbers, get them done, just to ensure that you obviously are ordering what you intend to order with this when you actually go to run your BOM. So that's a big one. The last one is the contacts tab. So this one's really important because what this one shows us is any child component that doesn't have a parent. As you saw when I inserted the child device before, no information goes to that child other than who the parent is, and then that drives all of the information. So if you delete the parent but don't delete the child, which the software will ask you to do, you'll delete a parent. It'll say, do you want to serve for children? And maybe you don't. Maybe you're just inserting a new parent and you're going to assign it to those children, and that's fine. But if you forgot to do that, now you've got child components that have no parents associated. So there's no information on those devices. They're in another dialog box, you'll see it references orphan children. It's a situation then where they're not getting any of the information that they need to be able to actually produce what's needed within the project. So those three columns, really, really, really important for you to do error checks on before you were to finish any project, in my opinion. So that is the auditing tools. There's obviously more on here. I'm not going to spend forever on them, but I just wanted you to see the top three and the reasons why we would look at those things. Okay, so now to all of the reports that we've been talking about. So those were the audits, but then we actually have reports. So you can run, there is a section of reports for schematic reports. There's also a panel one. I'll get there in a second. But if you were to look at this, what you can do, you can see all of the different reports that come out of the schematic reports. There is a bill of material here. This would be just on your schematic drawings. I don't recommend this as the one for sending to whatever your ERP system is, and I'll show you why, because that one will actually come out of the panel reports. But you can see there are wire from to lists. There are component lists. That would be everything, whether it carries bill of material information or not. There are PLC reports, terminal reports, cable reports, wire labels. So you can send this to, say, a Brady label maker. So you can run all your wire labels. Really great that you don't have to manually do any of this. You can run all of these reports. Every report has, and I'll show you with the bill of material, if I were to run it, every single report has the ability to be put on your drawing as a table or saved to a file format. And every one of them can go out to an ASCII, Excel, XML, CSV, or a Microsoft Access database file. So every one of those can be done. And typically what that means is whatever system you need to import that into can accept one of these file formats. Same thing, obviously, when it comes to your ERP systems for exporting out to pull in this data so that you can run your purchase list without having to recreate all of this in whatever your ERP system is. Now, the put on drawing, it obviously puts it on as an AutoCAD table object. So, and it goes a little version of that. That'll go away as soon as I'm done. It's just showing me where I'm zooming around. This one's obviously large. It's the whole project. So you can see, though, this is how it puts it in. So you can also put it on your drawing as a table. And you can have this, if it's this large and you wanted to actually live on one of your drawings, you can split it so that it moves across multiple pages. You tell it how many sections you want per page, and then it'll do that and automatically generate the pages needed. And as you get good with all your reports can then actually be done and set up in this automatic reporting tool where you can say every single time I have a project, I want it to run a bill of material, a wire from to list, a wire label, and a nameplate report. And when you do that, it will know if those go on the drawing or if they go out to a file format. You set all that up and then you just run it, and it's really easy to do. I do want to quickly show you the reports for the panels. Similar look and feel, but this obviously has less in it. And this is where you would get something like a nameplate report that I was mentioning if you wanted to say stamp your own nameplates, things like that. But this is the key, the bill of material for the full. So this is the full bill of material, including any schematic components not referenced in the panel. Obviously, you'll have things in the panel like nameplates, enclosures, things like that that would not be in a schematic. So it's important that you run it from here, but it will also go back and retroactively look if there's anything in the schematics that weren't displayed in the panel to include those. The other really neat thing is if you do the EMX workflow out of Inventor, so you do your panel drawings in Inventor, you can actually run your bill of material to include all of your Inventor parts as well. So your BOMs become combined. You're not running a separate BOM for both places. It's all one. So that's the beauty of this, and it's all done via AutoCAD Electrical, not inside of Inventor with its tools. It's all done within Electrical's reporting tools. So very, very cool things there with the reporting tools. Let's talk quickly, because I know we're coming up on getting close to the end of our time together here. So I'm going to talk about title block updates, plotting, and then hopefully we'll have a little bit of time at the very end to show you some of the automation that we have through PLCs. And then if you guys have any questions along the way, feel free to start. I don't have normally a ton of time at the end of this to address those. Please bring those to the office hours, but I will try to leave a couple minutes just in case there is. So feel free to start popping those into the question pane of GoToWebinar so that I can take a look at them and hopefully answer those for you before we leave. All right, so let's flip over in basic workflow to the paper space area. So kind of a common misconception. Some people feel that when you're in electrical, that means you don't need to use paper space. I 100% disagree with that. Paper space was designed to be your layout for printing, and we print electrical drawings all the time. So your title blocks should never live in model space. You shouldn't be scaling them up or down around your drawings. While I understand schematics are not really full scale, your panel drawings or your physical representations absolutely are. And all of that should be done in paper space by putting a viewport into your title block. Very, very easy to do. Very, very important, I think, to getting the proper setup to how you actually want these to plot as well. A lot of people that I talk to have issues with plotting, and then as soon as I take a look at their drawings and I realize they're trying to plot for model space all the time, that's why they're running into so many issues. If you just set up your paper space once in your title block, you'll really never have to think about it again. It's very, very easy to do. So just so you guys all understand why I'm taking you into paper space, I just wanted to explain that quickly. So let's look at the title block. So we can see here all of my title block information. AutoCAD Electrical has a setup for linking your title block attributes to fields within Electrical for it to automatically fill out. It's a very easy thing. Again, you do it one time, on your template, and then you never have to do it again. So if you were to then want to go do a title block update, I'm gonna update the descriptions, and I'm gonna make this job number 1, 2, 3, 4, 5. I'm going to change this to 11.7. It can be, yeah, we'll leave it engineered, drawn, and checked by me. It's a good checks and balance. And then we'll click OK on that. So I know we're updating those couple fields. And then individual drawing wise, each individual drawing carries its information on its own drawing properties where you can fill out when you first create the drawing what you want the standard descriptions to be, the sheet number, so you can have the things like 4 of 16 and so on. And then what we do is we just come up and say we want to do a title block update. We choose what things in the project file, so that would be done across all drawings, and then what things per individual drawing. And I'll have it do sheet number and sheet maximum. And then we just click OK project wide, and it will go through and it will update every one of our drawings. You'll see it do it very, very quickly. You'll see it scrolling through it in the project manager. You might see an update on here as well. It's already done this one, and it's done. Just like that. Command prompt is empty. I could jump in any one of these and take a look at them, and they're all updated. So really, really easy to do that title block update. Like I said, one of my favorite commands, so simple and easy, but such a time saver. So huge fan of that. Now, because of us setting these up and setting everything up the way that it should be for plotting, it makes going through something like our publishing tool here, and we want to go to plotting our project, very easy. So if you want to plot your whole project at one time, very, very easy to do that with our publish command. So that's a batch plot basically to send it all out. Now, the thing I want to focus on with you guys is this publishing to PDFs, DWIFs, or DWIF-Xs. Now, one of the coolest things that we have, we got this back in I think 2015 of the software, is we have the ability to plot to PDF with hyperlinks. So all of that amazing functionality that you saw me do when I surfed between parent-child, all of that, that then happens with the hyperlinks that we have within the PDF. So now you can send this to somebody who doesn't have AutoCAD Electrical, doesn't have AutoCAD, doesn't have any of those things, and they can very easily do the same navigation that you're doing within the software within the PDF, because it's now an intelligent PDF with those hyperlinks. So I just wanted to mention that and show that to you. Really, really powerful. Huge fan of the ability for us to do that. Okay, now one last thing to show you a bit more around automation that we have. I am going to go and we'll just add on to the same project. It's not a big deal if I do it. I've clearly done it on this one before. So what I'm going to do is I'm going to come over to my import export data, and I'm going to say that I want to do the spreadsheet to PLC-IO utility. Now it's going to use a spreadsheet that actually has all of my PLCs laid out and up to 9 inline devices to each IO point. And when I open that, I'm going to tell it I'm going to start on drawing 17. So it's going to, the ladder numbers are going to start at 1700. Your setup would already be defined by the template you have and all of that, and the drawing template that you're using, and what your spacing of your ladders are and your spacing between your devices. All of that's predefined. And then I'm going to come in and just tell it to start on the next available drawing number. So it's going to create a brand new drawing for me. I'm not using an existing one. I'll have it do a free run. It's going to be sheet 17. I want these in my active project, and ta-da, we go. And then, I should have changed the template. This is one of the native templates that comes with AutoCAD Electrical. I am not a fan of it where it puts the title block in model space, as you can imagine after everything I just described to you. So forgive me for using this one. I often forget that when I'm demoing this. I need to swap it to my title block in paper space, so my template that has title block in paper space. But so you can see it's already created one drawing. It drops the PLCs in. It drops all the inline devices. You can have as much information as you want in those inline devices. The spreadsheet can even carry things like catalog information, all the wiring connection. You can have it tee off. I actually did an AU course with one of our customers a couple years ago that we actually kind of tricked the PLC-IO utility to create and automate all schematic drawings for this particular customer. So we used it to kind of tweak and modify that so that they could get full automation out of their entire project set, which was really, really awesome. So go back and check that out on the AU boards. We're actually doing another automation class. I'm doing that with Rob Stein, one of my colleagues here at Autodesk. I'm also an AutoCAD Electrical expert. We'll be featuring some of those automation utility things as well at AU. So again, if you're going to be there in 2 weeks, please join us for that. I have 5 different classes that I'm going to be doing. So I've mentioned quite a few of them already, including the meetup, but please check them out. Please come take as many AutoCAD Electrical classes as you can, absorb all of this great info that we hope to bring you, and we hope you find value in it. So with that, I actually am done. I have 5 minutes to spare if any of you guys have questions. That doesn't happen very often. Sometimes I'm right up against the top of the hour, but if you guys have questions, please feel free to ask them. If not, I will give you guys a couple minutes back. Or I can show something else if somebody wants to see something else. Okay, I'm not seeing a ton of movement in the question pane yet, so I'm going to take that as no questions. Hopefully it's clearer than anything. That's the goal. Hopefully you're all excited about everything that AutoCAD Electrical can do for you, all the things that it can provide. I really do hope to see as many of you that are on here as possible at AU in 2 weeks. I'm thrilled to be there. Safe travels to anybody that's coming out, and those of you that aren't, hopefully we'll see you on the virtual version of it where we'll be joining you live from AU in 2 weeks. If you have anybody else that wants to see this, we do this, like I said, on the first Thursday of every month with this demonstration. And then the third Thursday of every month, if you are already an electrical user or you're getting started in it and you just have any questions. And like I said, beginner, intermediate, advanced, all are welcome. Also connected things are welcome. Like I said, I'm often joined by a vault expert and an inventor expert. So please feel free to join and ask any and all questions. All right, great to have you all join. Thank you so much for your time today. Good to speak to you. See you later.